Hello, ladies and gentlemen. Real quick, we're going to actually go through lesson 109 here because I wasn't able to actually be in the building to do it. 109 is talking about first degree polynomials, but this time we're going to talk about first degree trigonometric equations, not just normal algebraic equations. So just like I would solve over here, let me turn my pen on, right? Just as I would solve over here, you'd be 2x is equal to 1 and then x equals a half. I would do the same thing on this side with the cosine, right? So this becomes 2 cosine theta equals 1, cosine theta equals 1/2, right? But we're not done because the extra step is now finding what is going to be a half between 0 and 360. So we do, we're going to be in quadrant 1 and in quadrant 4, and we know it's positive, and we know that's a 60. So in quadrant 1, that is 60 degrees. And in quadrant 4, that's 300 degrees. Okay? So as we're doing that, then these are your answers. Instead of just being 1/2, your answers are actually 60 and 300. Now, it's not always going to be pi from 0 to 360. It might be limited. It might be whatever. But at the end of the day, it's still the exact same idea. And if we look at example number 1, we have this similar situation. Let's move this 5 over. 3 sine theta equals 2. Divide by 3, divide by 3. Sine of theta is 2/3. Now that's not going to come out to be nice and pretty like our 1/2 did, but it turns out that this is about 42 degrees. So we're going to be in quadrant 1 and quadrant 2. It's positive, positive. My reference angle is 42 degrees. In quadrant 1, that is 42 degrees. And in quadrant 2, that's 138 degrees. All right, making our answers there 42 and 138. Okay, similar question here at number 2, except this now is tangent. Add the 5, add the 5. 3 tan theta is going to equal 12. Divide by 3. Tan theta equals 4. Inverse tangent of 4 is going to get me about 76 degrees. So I'm going to be in 1 and I'm going to be in 3 because that's where tangent's positive. So it's 76 is about what it is. 76. In quadrant 1, that is 76 degrees. And in quadrant 2, that's 256. Because remember in quadrant 3, not quadrant 2. Quadrant 3 is 180 plus 76. All right, number 3 is a little different. Number 3's difference here is that it's talking about here. Yes, there's sine on both sides, but now we're talking radian. Solve it exactly the same way. So let's going to move this sine over here. Move this 1 over here. -1 equals 2 sine theta. Divide by 2. -1/2 equals sine theta. Now, -1/2, we know that that's going to be in quadrant 3, in quadrant 4, negative, and it's going to be 30. When you hit this in your calculator, you don't have to put in radians, leave it in degrees. You hit this in your calculator, and you're going to find that it's -30, or it's going to tell you -30, which means that it's really positive 330 in quadrant 4, okay? And in quadrant 3, you add your 30 on, that's positive 210. But that's not what we're looking for. We need it into terms of radians. So technically, this is a correct answer. Whoops, 180. Right? And this is a correct answer. Now, they're not in, good gravy. Sorry, ladies and gentlemen, note an extra 3. Let's try that again. 330 over 180 pi. Now, those are technically correct, except they're just not in simplest form. So when you simplify, this becomes 7 pi over 6, excuse me, I wrote 18, it's supposed to be 6. And this becomes 11 pi over 6. And those are your answers in radians. It doesn't say to, give a decimal approximation or anything like that, so we just do radians this way. Question 4, we're back to degrees again. Now I need to distribute. 5 sine theta plus 15 equals sine theta plus 12. Let's move everything around, right? Becomes 4 sine theta equals negative 3 divided by 4. Sine theta is equal to negative 3/4. That's going to be quadrant 3, and that's going to be quadrant 4 because they're negatives. And our reference angle here becomes 49 degrees. So in quadrant 3, that's 229. 229. And there's going to be 311. This one's got cosecant in it. Distribute. 3 cosecant theta minus 3 equals cosecant theta plus 2. Move this over. 2 cosecant theta. This goes over here as a 5. Divide by 2. Divide by 2. Now we don't have a cosecant button on our calculator, but we do know that that's the same as sine. So if I make this a sine, I take the reciprocal over here, and we're at 2/5. That's going to be quadrant 1, and that's going to be quadrant 2. Right? So, and I know I'm going to want this in terms of nearest tenth of a radian, but let's get the angle here. So this is going to be positive and positive, right? We know it's positive. And we know it's going to be 24, and that means it's going to be 156. Or, yes, it is going to be 156, but let's write the 24 there properly. Excuse me. 24, and then that's going to go to 156. Now they want this to the nearest tenth. So 24 pi over 180. That's going to give me approximately 0.4 radian. 156 pi over 180. That's going to give me about 2.7 radian. All right, last example here. Last example. You can distribute 3 cosine x minus 3 equals 3 minus 4 cosine x. Right? Let's move things around. So I'm going to move this becomes 7 cosine x. This equals 6. Divide by 7. Cosine of x equals 6/7. So we're going to be in quadrant 1, and we're going to be in quadrant 4. They're both positive. This is about 31 degrees as my reference. So let's say 31 degrees, and let's say 329 degrees. All right, folks, so I hope this video helps you kind of understand how to do this. Of course, if you have questions, you're always welcome to email me or ask me next time we're in class. Like I said, this was just day 1. Now, day 2 of this, we're going to get into second degree trigonometric equations. It's just first degree. So it means everything is just the leading coefficient, power is 1. When we get to the stuff next week, it's going to have a power of 2. So I hope everyone found this, informative. If you have questions, please make sure you just ask me. Thanks. Have a good one.